Okay, so before we move on to secant and tangents, I wanted to recap everything that we've learned so far. So I want to make sure we know what a chord, secant, tangent, diameter, and radius is. So on your paper, we're going to look first at line segment AD. So if I'm looking at line segment AD, what is that there?
Diameter.
Okay, it can be a diameter. What else could it be? A chord. Okay, so it could be a diameter or a chord. What about line segment CD? Is a radius. Very good. Okay, and then line EG, which is this line here. What type of line is it? Tangent. And then line HB, secant. Okay, so it's secant because it touches twice. Tangent only touches once. Okay, so the three formulas that you are going to need to know in order to do all your problems today are going to be these three right here. So yesterday we learned about inscribed angles. And why would this be considered an inscribed angle? Okay, it's what? It's on the circle. The vertex is on the circle. So when the vertex is on the circle, that means that our angle formula is going to be 1/2 of the arc. Okay, so it was 1/2 of the arc would be our angle measure. Now, today we're going to look at when they're inside and when they're outside. So when the vertex of the angle, let's say we were looking for angle ABD. If I'm looking for this angle when the vertex is inside the circle, what we're going to do is we're going to do the angle is equal to 1/2 of the sum of the arcs. Okay, sum means what? Add. So we're looking at the two arcs that are kind of across from the angle. So this arc and this arc would be the two we would add together. So we'd add AD and EC, take 1/2 of that, and that would be the angle. The last one you want to know is when we're finding an angle and its vertex is outside the circle. That's going to be 1/2 times the difference of the arcs. And again, you're looking at the two arcs that the angle is facing. So this arc here, which is a little arc, and then this big arc. Okay, so let's look at some examples of these. So in number 1, we're looking for angle measure ABC. So this angle, where is its vertex? It is on the circle. So if it's on the circle, we're doing 1/2 of the arc measure that it's across from, and it's across from 120. So ABC would equal what degree measure? 60 degrees. Okay, let's look at number 2. So in number 2, we're looking for angle measure ANT. So ANT would be this angle measure here. Okay, where is the vertex of this angle located? On the circle. Okay, so we're going to use the same. We're looking for the angle measure that corresponds with this arc. So we would do 1/2 of this angle measure, which is 90. Okay, so if we half 90, our angle measure equals 45. Okay, so how do we feel about on the circle? Good? All right, let's look at some more examples. So now we're going to move on to number 4. We're looking for measure TEX. So TEX is this angle right here. Where is the vertex of this angle located? Inside, okay? And so our formula for inside was 1/2 times the sum of the arcs. So which two arcs are we using here? 35 and 65. So we would do 1/2 of 35 plus 65. That would be 1/2 of 100, and so half of 100 is 50. So our angle measure is 50. Okay. Now in number 5, we're looking for angle measure RPK. So this piece here, where is its vertex located? Inside, on, or outside? Inside. Okay, so we're using the same formula. So we're doing 1/2 of the sum, which is 33 plus 39. That would be 1/2 of 72. And if you half 72, angle measure RPK equals 36 degrees. Okay? Now, let's look at 7. So in 7, we're trying to find our x value. Since x is all the way in this corner right here, that means it's talking about this angle measure. So where is the vertex of this angle located? Outside. So this time our formula is going to be 1/2 of the difference of the two arcs. So would it make more sense if we did 60 minus 20 or 20 minus 60? 60 minus 20, because that would give us a positive answer. So that would be 1/2 of 40. And half of 40 is 20. So x would equal 20 degrees. Okay, let's try one more of those. So let's look at 8. In 8, again, we're finding this measure in the corner. My vertex is outside of the circle, so I'm using the formula 1/2 times the difference. So we would do 1/2 times, we always do biggest minus smallest, so 128 minus 22. So 128 minus 22, that gives me 106. And if we half 106, my x is going to equal 53. Okay, so I want you to flip to the back, because on the back, they give you a bunch of information that you don't necessarily need. So I want you to be able to distinguish what information you need and what information you can kind of just throw out. So let's look at number 1. For number 1, they want me to find the measure of GKM. So GKM is this angle measure right here. What arc is across from this angle measure? 150. Okay, this angle is pointing at 150. Is it pointing at 210? No, it's not even facing 110. So we will not be using 110. Now if it's on the circle like it tells us, we're going to half our arc measure to equal the angle. So if I half 150, my angle measure is going to be 75. Okay, let's try one more of those. So in number 2, they want us to find angle measure JLP. So JLP would be this angle here. Which two arc measures do I not need? 102 and 170, because we know this is pointing to the 88. So we would half this, and our angle measure would be 44. Okay, let's try inside the circle. So this time I'm looking for angle RUN. RUN would be this angle right here. Now, since it's inside the circle, how many arc measures are we going to have to use? 2. Okay, which 2 would we want to use? 88 and 60, because 80 is across from this, and then 88 and 60 are opposite, so we do not need 96 or 116. Our formula for this is 1/2 times the sum. So this would be 1/2 of 60 plus 88. 60 plus 88 gives me 148, and when I half 148, I get 74. Is everybody with me so far? No questions? Okay. Let's look at angle UPS. So UPS would be this angle measure right here. What 2 angle measures do we not need, Brittany? Right. We do not need arc measure 106 or 114. So we're going to do 1/2 times the sum of 78 plus 62. That would be 1/2 of 140, right? And half of 140 is? Thank you. 70 degrees. All right, last, let's look at some outside ones. So in 7, they asked me to find x, which is this angle in the corner. Since I can clearly see, and it gives me that it's outside, we're doing 1/2 times the difference. So which 2 measures do I not need, Caroline? 211 and 67. So that means I'm going to do 1/2 of, do I do 66 minus 16 or 16 minus 66? 66 minus 16. So that would be 1/2 of 50, and half of 50 is 25 degrees. Okay, let's try one more of those. So in let's do number 9, because number 8 actually doesn't give us anything that we don't need. So in number 9, we're finding this value of x. So which one do we not need there, Seth? 242. So we would do 1/2 of 86 minus 32. That would be 1/2 of 54. And half of 54 gives us 27 degrees. Okay, now I want to talk about when you're trying to find the angle, but you're not actually given the arc measure. So remember that we said that our formula for angles whose vertex lie on a circle is 1/2 times the arc. Okay, and we're going to be using the fact that circles measures add up to 360. Linear pairs are 180, and vertical angles are equal. So looking at number 1, they want us to find measure B and K. So angle measure B and K would be this angle right here. It is facing this arc, but this arc doesn't actually have a measure. So we're going to have to find it. Now, we know that circles add to be what? 360. Okay, how many pieces of a circle do we have here? I have this piece, which is 256, and then I have a second piece. So there are 2 pieces. So these 2 pieces should add to be what? 360. So I could just subtract 256 from 360, and that's going to give me what's left of the circle. So when I subtract the 2, that's going to give me 104. So I now know that this arc measure is 104. Okay? So now we just plug into our formula. We do 1/2 of 104, and my angle measure equals 52 degrees. Very good. Okay, let's try one more of this. So let's look at number 2. In number 2, they want us to find angle ADF. So this angle right here. This angle is across from this arc measure, which we're not given, so we need to find. This time, how many pieces is the circle cut into? 3. So that means that 112 plus 112 plus the piece we're missing, we can let it be x, should equal 360. So if I add 112 and 112, that gives me 224. Then I can subtract 224. And my arc measure will equal 136. So if this arc measure is 136, to find our angle, we half that. And so our angle would be 68. Very good. Now let's look if it's inside the circle. So if the vertex lies inside the circle, our formula is 1/2 times the sum of the arc measures. So here we're looking at angle BUG. So BUG is this angle right here. Now, we know that this whole circle should add up to be what? 360. How many pieces is it cut into? 4. Okay. So if I'm only missing 1, I can add the other 3 up and subtract from 360 and get my answer. So 112 plus 144 plus 62, that will give me 318. Then I can subtract that from 360 to get my missing piece, which is 42. So if this is 42, what are we actually adding together? What 2 arc measures? 42 and 144. So we're doing 1/2 of 42 plus 144. We don't actually need 62 or 112 because they're not opposite of this angle measure. So when we add that, that gives us 1/2 of 186, and half of 186 is 93 degrees. Okay, let's look at 5. So in 5, we're finding measure HAT. So this angle right here. Now, we need 2 arc measures, right? We need this arc measure and this arc measure, but we're not given either one of them. So do y'all have a guess of how you would do that? Okay. What did you end up getting when you did that?
That's what I got.
Okay. solved it different as well. So that would work. Sarah said vertical angles are equal. So you added 127 and 57, subtracted from 360 and divided by 2? That's what I did. I looked at this as a half circle. So if I did 180 minus 127, that would give me 53. So this piece would be 53. And then you could do the same thing here because this is half a circle. So 180 minus 57, and that would give you what? 123. Thank you. And so then to find my angle, I would do 1/2 of this arc, which is 53, plus this arc, which is 123. So when you add those, that ends up giving you 176. If you half that, you end up getting 88 degrees. So Sarah, the way you did it, you got the right answer. I don't know if it always works. Did you do the same? Okay. Okay, and I do want to show you the outside circles, or when the vertex lies outside the circle, because that's the one that most people make the mistake on. And so the formula for if a vertex is outside the circle is 1/2 times the difference of the arcs. So again, you want to look at how many pieces the circle is going to be cut into here. So we're looking for this angle. I need this arc measure, which is 40, and I also need this arc measure. How many pieces of the circle are there? I see 1 here. I see 2 here, 3 here, and 4. Okay? So that means that if I added all 4 together, they should equal 360. So I'm going to let this be x, and I'm going to do 60 plus 40 plus 100 plus x equals 360. When I add all my like terms, that gives me 200 plus x equals 360. I subtract 200 from both sides, and so I find out that this piece here is 160. And then my formula is going to be 1/2 of the bigger arc, which is 160, minus the smaller arc, which is 140. So that's 1/2 of 120, and half of 120 is 60. So x equals 60 degrees. Okay, we're going to do one more of those, and then I will let you know what your homework is. Okay, so in number 8, how many pieces does this angle cut the circle into? 2. So all I would have to do is subtract 256 from 360, which would give me 104. So this small arc here is 104. So I would plug into this formula, and my angle x is going to equal 1/2 of 256 minus 104. When I do 256 minus 104, that gives me 152. And half of 152 is 76 degrees.